Hi everyone. Let's look at dividing polynomials. Now, if you haven't seen the video on factoring yet, I'd highly encourage you to see that, or at least just at the very least, make sure you're familiar with how to factor and how to factor things like quadratics and just normal numbers, any other kinds of factoring. Because there's two different kinds of factoring. When we say factoring, it might mean doing two different things. And that's another video. So, because we'll need that for this. But this video's lesson is about dividing polynomials and figuring how to do that as best as possible. So we'll look at this first problem and just jump right in. We've got 12a to the third plus 2a squared plus 18a divided by 6a. When I run into a problem like this, the first thing I like to do is turn the division sign into a fraction, because it kind of helps me make more sense of it. If that doesn't help you, then don't worry about it. There's other ways of going about it too. But just for the sake of simplicity, I'm going to try to do this. If you want to do it the other way, if you want to work without it being a fraction, you can still do the same things I'm telling you. Just make sure that it is just make sure you're doing the same things. But it all works the exact same way if it's not a fraction. Okay. Here's how we can accomplish this. Remember in the last video I talked about terms, how the way to find the different terms of something is by figuring out where the plus and minus signs are. So in order to accomplish a problem like this, especially a problem where it's just a 6a, there's other ways of accomplishing this division problem, but we'll start with the easy one. This is the easy way to solve this problem, assuming it's just one term. If you've got one term on the right side, this is one term. Let me just kind of specify this. This is the process for one term in what's called the divisor. Okay. This is the process for one term in the divisor. That's what we're trying to do here, and you can see there's other ways to do the other problems, and actually, in all reality, you could use the other problems. You could use long division to solve this problem, but if you we'll do long division on this too, just to show that it comes at the same answer. But however, you can still use this, and this will work just fine. This is probably the fastest way of doing it. If there's one term in the denominator, one of the easiest ways of doing this is just applying that divisor to every single term. Here's what I mean. We'll take the divisor and we'll apply it to the 12a3 to the cubed. So it'd be 12a cubed divided by 6a, and that's one term. And we do the same thing for the next term. 2a squared divided by 6a, and then 18a divided by 6a. Three different terms, so three different divisions. That's one way of doing this kind of division problem. Okay, and we can kind of do this. If you saw the factoring problem, the factoring video, you can probably see how we accomplish it from here. The 12 divided by, let's start with the first term. The 12 divided by 6 is 2. A cubed divided by a is just a squared. And let's see, 2 divided by 6 is 1/3, so we'll do 1/3. And let's see, a squared divided by a is a. And let's see, that's that one. And the 18 divided by 6 is 3. And a divided by a is just 1. So 3 times 1, which you can just say 3 times 1 is just 3. So that works that way. And that's simply our answer. That's all there is. That's all there is to it. So if there's one term, just apply that 6a to all of them. Now, you can use long division here as well. Here's long division. So we'll do, let's see, that was, we'll make a little division, we'll make a little partition there. So we'll do 6a divides into 12a to the third plus 2a squared plus 18a. Okay, 6a divided by 12a cubed. That goes in how many times? That goes in, let's see, that goes in 2 and 2a squared, because 12a cubed divided by 6a. Remember from long division how to do that? We're going to go into this more thoroughly later. This is 2a squared. Yeah, so we're at 2a squared up here. We'll multiply that through, so that gives us 12a cubed. And we'll subtract, and that gives us 0. Bring down 2a squared. Let's see, 6a goes into 2a squared. Let's see, how many times? If you really want to get technical about it, it goes in 1/3 a times. So let's see, 2a squared divided by 6a, that is 1/3 a. So we'll write 1/3 a plus 1/3 a. Don't let the fraction scare you. That's just how the division problem worked out this time. 1/3 a times 6a is 2a squared. Subtract it out, that gives us 0, bring down the 18. And we've got 18a, and we'll do 6a, 18a divided by 6a, 18a divided by 6a. That gives us, let's see, that gives us just 3. So we'll put 3 up here, and we'll get 18a, subtract, and we get 0. Okay, and that would be the other way of finding this answer if you didn't want to have to go through this first process. Two equally good ways of doing the same thing. The first one might be a little bit faster, but both of them work. So that's the first way. That's the first kind of problem. This is distinctive about this one is that there's a one term in the divisor. I hope you can read that, one term in the divisor. All right. So now the second type of problem we do is if the division is specifically an x minus something, or a variable minus or plus something. Not like 2x minus something or 3x minus something. It has to be just x minus something or x plus something. So in this case, you've got p minus 8. So it's like an x plus some number. And it's just x plus a number. This is the process for something like that. We use synthetic division. Again, you could use long division here too, but synthetic division is much, much faster. See, in a problem down here, where long division is required because you got a 2x, or 2p plus 8. And so synthetic division won't work in a problem like that. You'll need to just use synthetic division for just problems that have this. And the reason why we use synthetic division is because it's so doggone fast. It's much, much faster than long division. And so we like to use that here. In the next section, we'll show how to do long divisions too, and you can use that here as well. Let's look at synthetic division. To use synthetic division, we'll take the number in the divisor, we'll change the sign. So we'll change the sign. So change sign. And we'll put that in the box right over here. So from being a negative 8, it'll become a positive 8. That's the first bit. The second bit is taking all of these numbers. Let's change colors so it's just clear what we're doing. Let's use a green, because I like green. All right. We're going to take all these numbers, and we're going to, just all the coefficients, and we're going to put them right beside it. We're going to put them right over here. Now, here's the catch, though. We got to make sure that there is a coefficient, there's a number for each different type of p. Here's what I'm trying to get at. If we had like 3p cubed minus 2p squared plus 20 plus 12, something like that, we're missing a p to the 1 power. We need to count down with the p's all the way to 0. So we'd have to plug in a 0p just because or to the 1, or just 0p, because those are the same thing. Same idea over here. If this was a p to the 3rd power, we need to plug in a 0p squared just to get it all to be situated correctly. That's very, very important. Make sure you don't forget that. But unfortunately, we do not have to worry about that in this particular kind of problem because everything does line up correctly. There's a cubed, there's a second power squared, there's a first power, like p to the 1, or just p, and there's a number. So we're good to go. We'll plug in the coefficients, and remember there's an imaginary 1 being multiplied by every single number all at once. So if it's missing a number beside it, we can plug in a 1. So we'll plug in a 1 minus 10 and 22 on the right. Great. And then we'll go ahead and do the process. And here's the process. You bring down the 1, and then to bring it up, we've got to multiply it. We got to multiply it by the 8. So we get 1 times 8 is 8, 10, negative 10, and then to bring it down below the line, we'll add. So negative 10 plus 8 is negative 2, and then 2, bring it back up again. 2 times 8 is negative 16. Negative 16 plus 22, or 22 plus negative 16, both mean the same thing, is 6. Okay, we got 1, 2, and 6 as our answers. 1, 2, and 1, negative 2, and 6. And so we will, to finish off the answer, here's how the answer looks. The last number is a remainder. So we've got a remainder of 6. The next number is just a number, so minus 2. And the number after that, it starts with x to the first, is x. So we get x minus 2, remainder 6. You can write the remainder as a fraction if you want to. If it asks for it in a fraction, you just take that remainder and you put it over the beginning. So if you want to write it as a fraction, you take this beginning and put that at the bottom. So you put that at p. Actually, let's make this smaller. P minus 8, and you put the 6 on top, and you write x minus 2 beside it. That's another way of writing the answer, with the remainder, plus 6 over p minus 8. So that's synthetic division. That's the really fast way of doing division. If it is x plus a number, not 2x or 3x or anything else, just x plus or minus a number. Great. The last one is long division. And again, long division can be used for all of these, but it takes a while. It takes a few minutes. It also might be the most intuitive if you're familiar with how to do long division without the other numbers. But maybe not. Who knows? So let's look into it. Let's see how to do this. 2p plus 8, or 2p squared minus 6p minus 60 divided by 2p plus 8. You'd set it up like you would set up any other division problem that you remember from elementary and arithmetic. So you do 2p minus 8, and we'll divide that into 2p squared minus 6p minus 60. Okay, now here's the process. Here's where it gets a little bit different from what you're used to. Again, before we get into that, remember the same rule still applies. If there was a p, there's a p squared. There's a p squared here, and there's a p to the first here, and then there's just a number. So it counts down correctly. There's no need to add any extra numbers. Just want to clarify that up real quick. If there are any missing numbers, you want to put those in too. So if there's like a 5p to the fourth to the right, then we'd have to plug in a 0p cubed to bring it down to 4, 3, 2, 1, 0. But none of that is there, so we don't have to worry about any of that. It's all good as is. Just to clear up any confusion that you might already have. Okay, to do this division problem, we take the 2p, we take the first term of what's called the dividend, and we divide that by the first term of the divisor, and that's our first answer. So we get 2p squared divided by 2p, and that's what I was doing at the beginning of this video. And we divide that through, let's see, 2p squared divided by 2p, if you remember from the factoring video, that becomes, let's see, 2 divided by 2 is just 1, and p squared divided by p is just p, so that just gives us p. All right, so we'll put in p for the first one, and you could put it anywhere you want to. Just for neatness and orderliness, I like to put the same power. I like to put it above the power that it has in the dividend. So there's a p to the first power, just a p right beneath the p answer. In other words, I like to put it here instead of over here, just because it just makes it neater for me. But you can do whatever you want. This is your problem. You can do whatever you like. We'll take the p and multiply it through. So we'll get 2p, I feel like Bob Ross, 2p squared, and multiply it, so p multiplies by the 2p to get 2p squared. You multiply the p by the negative 8 to get minus 8p. And then from there, I'm messing things up. Then we subtract. we subtract the whole thing. Or in other words, we just change the signs. So this becomes a negative, this becomes a positive, and we combine them. So 2p squared minus 2p is 0. Negative 6p plus 8p is 2p. Okay, then we do it again. Except this time, we divide this 2p by the first term, that 2p. Don't want to forget to bring the negative 60. So 2p, bring the negative 60, and then we're going to divide it through. So here's how we divide. We'll get 2p divided by 2p. 2p divided by 2p. Well, that's just 1. So we'll plug in a positive 1 for the answer, and we'll multiply it through. 1 times 2p is 2p. 1 times negative 8 is negative 8. And we will subtract. And in order to subtract, we just change the signs. So again, what I did before is I subtracted the whole thing and I distributed the negative. If that doesn't make sense, don't worry about it. Just change the signs of the seconds, of the bottom numbers. So it becomes a minus 2p and a plus 8. So 2p minus 2p is 0. Negative 60 plus 8 is negative 52. So we get p plus 1 with a remainder of negative 52. So that'd be our answer. We write p plus 1 with a remainder of negative 52. Or we could also write, if you wanted to, you could also write p plus 1 in fraction, with a fraction remainder, minus 52 over 2p plus 8. And those are both answers, whether or not you want fraction form or remainder form. All right, last problem. This one's really hairy and really messy, so we'll jump right in and see what we can do. It says 30x squared minus 40x divided by 15x cubed minus 20x squared, and all that divided by 10x over x minus 1, or x plus 1. So we had to figure out what is the best route to move forward here. What is the best thing to do? Well, the first thing to notice is that there's this division sign in the center, and that's really the key to what's going on here. There's a division side, and another side is on both sides is a bunch of gobbledygook, and this can become really overwhelming. All this gobbledygook over here, and all this gobbledygook over here. So we'll start with what we can work with. The first thing, what is clear and not so confusing. Do the easy stuff first, and then the rest of it can maybe somehow work itself out. That's a general rule of math. Try to do the easy stuff first, and even life, I suppose. But the major thing, the thing that's linking them together, the major thing is the division sign. So that division sign is that first thing we want to do because it's the main thing. It's the star of this show. Okay, so that tells us where to start off with. We want to start with that division. And how do we tackle a division problem, especially a division problem that involves fractions? Well, you may remember that a division problem that involves fractions. If you had 3 over 4 divided by 2 over 6, you may remember from arithmetic that in order to accomplish a problem like that, we would keep the first side, 3 over 4, we would change the division to multiplication, and we would flip the 2 over 6. We'd make that a 6 over 2. And that's how we'd move forward from there. That's not what we have here. I mean, we have a bunch of extra, more complex stuff. But we can do the same principle. We'll keep the left side, 30x squared minus 40x. And we'll divide that by 15x cubed minus 20x squared. And we'll keep that side. We'll change the division to a multiplication. And I'm using a dot instead of an x because I don't want to get that confused with the x's in the problem. And we'll flip the other side. We'll flip the 10x over x plus 1 to be x plus 1 over 10x. Okay, that was step 1. So we're already finished with the first part of it. That's step 1. Step 2 is to multiply. We're going to multiply. We're actually going to do the multiplication bit and see what we come up with. So we will multiply this with this. We'll multiply the bottom with the bottom. We'll start with the tops. So 30x squared minus 40x times x plus 1. This is step 2, by the way. Step 2. And we're going to divide all that by 15x cubed times, that's minus 20x squared, 20x squared times x plus 1. That's a minus, just so that we're clear here. Okay. Oops. Sorry, that's a 10x. That's not an x plus 1. See, it's really easy to make mistakes. It happens all the time. Okay, let's go ahead and do the top part. The top part, you may notice, to solve the top part, that's a simple foiling problem. Well, foiling isn't necessarily simple, but that's the way to accomplish this. So we got a binomial times a binomial, sort of firsts, outers, inners, lasts. Start with the firsts. The first is 30x squared. Let's see that the firsts is 30x squared and x, which gives us 30x cubed. And then we'll do the outers. The outers are the outsides, the last one, the beginning and the last one. So that gives us 30x squared times 1. That's plus 30x squared. Then we'll do the inners, which is the stuff on the inside. So minus 40x and x. So let's see, minus 40x times x would be minus 40x squared. Minus 40x squared. And then finally, we'll do the last two that haven't that haven't been used twice yet. The lasts, negative 40x and the 1. So negative 40x times 1 is negative 40x, because anything times 1 is itself. Great. So that's the top. That's the top. And the bottom, let's see that the bottom is 15x cubed times 10x. That'd be 150x to the fourth minus 20x squared times 10x is minus 200x cubed. So I just took 10x and I distributed them through, just like this. So I multiplied 10x by the 15x cubed and the 10x minus by the negative 20x squared. That's how we kind of distribute one term into two. It would have been the exact same if it were 10x times 15x cubed minus 20x squared. Both those would have done the same thing for us. We would have done the exact same process. We would have taken 20x and multiplied that way and that way. I'm doing the same process in both ways. But this is our problem, so this is what we worked with. Okay, 150x to the fourth, let's write that a little bit clearer, 150. Great. Now that we've multiplied everything through, actually, we haven't finished. Let's simplify this a little bit. 30x cubed, and then, let's see, 30x squared minus 40x squared. Oh, that's simple, we know what that is. That's minus 10x squared. 10x squared, and then minus 40x. Okay, so we've kind of simplified this down as far as I can. We've kind of multiplied this through and kind of simplified it a bit. We've got 30x cubed minus 10x squared minus 40x all over 150x to the fourth minus 200x cubed. So I guess in the second step you also do a little bit of simplification if you can, and simplify. I'll just add that in. So simplify if necessary. In this case, we could simplify, so we simplified. The third step is it's almost like we undo what we just did, but we're going to go ahead and factor this out, this beast out, as best as we can. Okay, we'll start with the top bit and see what we can factor out. Let's see. We don't have a quadratic. It's not a quadratic, and it's not even, if it's not a quadratic, we gotta factor it the way we factor anything else out. We gotta if you go back to the factoring video, if you don't remember how to do this, but we'll put parentheses around it. So 30x cubed, and minus 10x squared minus 40x. So because it's not a quadratic, we're just gonna start pulling numbers out of it. We'll pull out, let's see, what can we pull out? We can pull out an x. We can do that. Let's see. So that would give us, let's see, if we pulled out an x, that would would change this to a, let's actually keep the colors consistent. So we will pull out an x and make it 30x squared minus 10x minus 40. Okay, anything else we can pull out? So let's see, let's just rewrite this. So this is x, let's see, I'm kind of moving over here, x times 30x squared minus 10x minus 40. What else can I pull out? I can pull out, let's say 10. I can pull out 10. So we'll pull out a 10. So 10, let's see, that becomes a 3x squared. This becomes a minus 1x, or just minus x. It's probably more accurate, minus x. And, well, they're both just as accurate. And then a minus 4. All right. And so that gives us 10x, and then 3x squared minus x minus 4. That's all I've done. So I've pulled out what I can pull out. A 10x is what I've gotten. And so I've factored that out a bit. And now I've got a quadratic. And now that I've got a quadratic, I'm going to try to use the AC method and see if I can figure this out. Maybe there's a way to factor this out just a little bit and get some headway here. So let's see. I'm going to try to factor out this with the AC method now that we have a quadratic here. So I'll use the AC method. I put 3 times negative 4 at the top, so it's negative 12 AC. And for B, I'll put a minus 1. Again, factoring video if this is all confusing for you. Okay, so we need to find two numbers that multiply to be negative 12 and add to be negative 1. So I'll make my factoring table be 1 and 12 is 1. I can't, those don't add to be, there's no way to add those to get to 1. There's 2 and 6. Those don't add to be 1. We got 3 and 4. Oh, 3 and 4. I can do 3 minus 4 to get to 1. Okay, so that actually works pretty well. If I use 3 and minus 4, 3 times minus 4 equals negative 12. 3 plus negative 4 equals negative 1. So I'm good to go. That means that I'll have 3x squared plus 3x minus 4x minus 4. And I'll put all that in parentheses and group them like this. Let's see, let's make this a little bit cleaner because that's really messy. There's a lot going on here, but there's no need to be messy. Okay. So let's see, we've got that, and then we'll factor out again. We'll get, let's see, I can factor to 3x on both sides, 3x for the first one, and we're left with x plus 1, I believe. And I can factor out a negative 4 to make it the same on both sides. So plus a negative 4. And we'll get a x plus 1. All right, so these two numbers, these two are equal, which means we're good to go there. So this is turning out pretty promising, which means that to factor out of that quadratic, we have 3x minus 4 and x plus 1. Those are the factors of that quadratic formula, of that quadratic equation. So we get those two factors. There's one more factor that we have as well. We can't forget this 10 that we got way at the beginning. So bring all the way down. So we get 10x, and then 3x minus 4 and x plus 1. Those are all the factors of the numerator. Great. We factored out the numerator. That took a while, but we got it. We got it done. So 10x times 3x minus 4 times x plus 1. That is the numerator factored. Now we need to factor the denominator and see if there's anything else we can pull out there. Okay, so 150x to the fourth minus 200x cubed. Let's see. Let's do maybe a pink here. Okay, and I'm gonna factor this out. And because it's not a quadratic, we gotta do the normal factoring method. So we'll do 150x to the fourth minus 200x cubed. And we'll see if there's anything we can pull out of both of them. It looks like I can pull out a 10 to start with. Let's see, I'll pull out a 10, and let's see. Oh yeah, I'll pull out a 10. That's a weird color, I should change that. That'll be a, let's say that'll be a 10, a silver. So that's fine. Okay, so we will pull out a 10. I can pull out a 10, and that gives us, let's see, that turns to 15x to the fourth, and this turns to minus 20x to the third. So we're left with 10 times 15x to the fourth minus 20x cubed. What else can I pull out? I can pull out 5, so I'll pull out a 5. And let's see, that gives us a 5 times 10. Let's see, so that gives us a 3x to the fourth, and then that gives us a minus 4x cubed. All right, so that's about as far as I can go as far as the numbers go. So we get 5 times 10, that's 50. 3x 4 minus 4x cubed. What else can I pull out? I can pull out some x's. I can't pull out any more numbers, but I can pull out some x's. There's an x cubed is held in common between the two terms. So I'll pull out an x cubed. And let's change the color to an orange. Okay, so I'll pull an x cubed. And let's see, that gives us 3x4 divided by x cubed is just 3x. And over here, my negative 4x cubed divided out, that is minus 4. So we get 50 x squared, oops, not x to the x power, that's a whole different kind of problem, times 3x minus 4. And there's really no other way to factor that 3x minus 4. That's as far as I can go. You can, when it's down to just x to the first power inside the parentheses, it's there's nothing more you can factor as far as the x goes. Maybe you can factor the numbers, pull out some extra numbers, but you can't pull out any more x's for certain. So that's about as factor as it can go. So our denominator, that was a lot easier to factor out. Let's see, 50x squared times 3x minus 4. That was the factoring of the denominator. That was step 3, my friend. Step 3, that was all of that. But this brings us to the last bit of the problem. These are really nasty problems, but they are doable problems. You can do them. They just take a long time. So let's finish it. So the last bit is just cancel things out. Cancel out what you can cancel and divide out what you can divide, and then we'll be done. So 3x minus 4 and 3x minus 4, those can cancel because that's the same thing. So that leaves us with, let's see, 10 and 50. Let's see. The 10x, the 10 divided by 50 can leave us with, you can cancel out a 10 there. You can divide both the top and the bottom by 10. So that gives us, let's see, 10 divided by 10 is just 1, so it just gives us an x at the top. This comes, if I divide by 10 on top and divide by 10 on the bottom, the top is up with x. The bottom is left with 50x squared divided by 10. That is just 5x squared. Okay, so x divided by 5x squared. Don't want to forget the x plus 1 on the right. And let's see. I can divide the top and the bottom by x as well. I can divide the top by x and divide the bottom by x. So x divided by x, that just cancels out. And x divided by x squared, that would be just x. So this would be x divided by x squared, just x. So that leaves us with x plus 1 over 5x. And I think there's nothing more we can do there. Yeah, that's about it. That's as far as we can go. We've canceled out everything we can cancel. We've done the divisions we can do. And that, my friend, is our answer. That was a lot of work and a lot of effort, but I believe you can do this. I really think you can get it done. It takes a lot of work, but man, I've seen all of you all and how hard you work in class and how hard you can work in class. And like you guys can get this. This is doable. You are able to master this, and I'm really encouraged by how hard many of you do work in class. I have been working in class, and anyway, I'm looking forward to seeing how well you do with this. Again, if you are having any trouble at all, I am here to help you as best as I can in any way I can. So please come to me. I am here to do whatever I can to set you up for success. Because if you can conquer problems like this, you can conquer the worst of it in the college entrance exam. So looking forward to seeing your work. Let me know if you have any questions. I'm here to help you. Thanks.